Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
You've built multi-region architecture across 13 episodes. Aurora replicating data, DynamoDB active, EKS clusters running workloads, observability showing what's happening, compliance documented for regulators. But here's the uncomfortable question. What if an attacker gains access to US East 1? Can they automatically access US West 2? Can they decrypt replicated data? Can they steal secrets from Secrets Manager? Multi-region increases attack surface. Every region is a potential entry point. Every cross-region connection is a potential interception point. Every replicated key is additional exposure. Today, you're learning security architecture that protects multi-region without compromising functionality. Not security theater. Real protection that survives sophisticated attacks. By the end of this lesson, you'll understand encryption at rest and in transit across regions. AWS, KMS, multi-region keys versus per-region keys, and the security trade-offs. Secrets Manager replication with least privilege access. IAM policies that prevent lateral movement between regions. Zero trust networking with VPC endpoints and private link. And security mistakes that turned multi-region into multi-vulnerability. Because security isn't optional. It's the foundation everything else depends on. Let's start with encryption in transit. Protecting data as it moves between regions. Aurora Global Database replicates transaction logs from primary to secondary regions. This happens over the AWS internal backbone network, not the public internet. But internal doesn't mean secure by default. Aurora automatically encrypts replication traffic using mTLS 1.3. You don't configure this. It's built in. The primary region encrypts the transaction log before sending. The secondary region decrypts on receipt. Even AWS employees with physical access to the backbone network cannot read your data in transit. DynamoDB global tables work similarly. Replication between regions uses the AWS internal network with automatic encryption. Again, mTLS 1.3. No configuration required. But application traffic between regions? That's on you. EKS pods in US East 1 calling services in US West 2 need TLS. Episode 11 Service Mesh with Istio provides this automatically. Envoy sidecars establish mutual TLS connections between pods. Even if an attacker compromises the network, they see encrypted traffic. Without a service mesh, you configure application-level TLS. Your API servers use HTTPS with TLS 1.3 minimum. No TLS 1.2 due to known vulnerabilities. Absolutely no TLS 1.0 or 1.1. Real security incident. A financial services company, multi-region architecture, used internal service-to-service communication over HTTP, not HTTPS. They assumed the AWS internal network was safe. An attacker gained access via a compromised EC2 instance, sniffed internal traffic, captured API tokens, and escalated to full account compromise. Post-mortem. All internal traffic must use TLS regardless of network location. Now encryption at rest with KMS, protecting data stored in Aurora and DynamoDB. Aurora and DynamoDB both support encryption at rest using AWS KMS keys. When you create an encrypted Aurora cluster, you specify a KMS key. Aurora encrypts data files, backups, snapshots, and transaction logs using that key. Same for DynamoDB tables. The question for multi-region, single KMS key or multiple keys per region. Option 1, per region KMS keys. Create a separate KMS key in each region. The US East 1 Aurora cluster uses a US East 1 KMS key. The US West 2 Aurora cluster uses a US West 2 KMS key. Data replicates encrypted, but each region's data is encrypted with a different key. Advantage: regional isolation. Compromising the US East 1 KMS key doesn't expose US West 2 data. An attacker needs to compromise both keys separately. Defense in depth. Disadvantage: complex key management. When you restore a snapshot from US East 1 to US West 2, you must re-encrypt with the US West 2 key. This adds time to disaster recovery. During Episode 12's Aurora promotion, you're waiting for re-encryption. Option 2, multi-region KMS keys. AWS supports multi-region keys that replicate automatically. Create a multi-region primary key in US East 1. Create replica keys in US West 2, EU West 1. All regions can decrypt data encrypted by any replica. The key material is the same across regions. Advantage: simplified drive. A snapshot encrypted in US East 1 can be restored directly in US West 2 without re-encryption. Faster failover. Lower RTO. Disadvantage: single point of compromise. If an attacker steals key material from any region, they can decrypt data in all regions. Reduced isolation. Which to choose? Depends on your threat model and RTO requirements. Financial services with strict security, per region keys despite slower drive. E-commerce optimizing for speed, multi-region keys for fast failover. Real implementation. A healthcare company, HIPAA compliance. Uses per region KMS keys for maximum isolation. DR testing showed a 15-minute delay for Aurora snapshot restore due to re-encryption. They accepted this. The alternative was an unacceptable risk of a single key compromise, exposing all patient data across regions. Now KMS key policies that actually secure your keys. The default KMS key policy allows full access to the account root user. This is too permissive. Root compromise equals total key compromise. You need least privilege key policies. Example key policy for an Aurora encryption key in US East 1. Allow the RDS service to use the key for encrypt/decrypt operations. Specify a condition. Only for RDS resources in the US East 1 region. This prevents an attacker from using a stolen key to decrypt data in EU West 1. Allow specific IAM roles to use the key. Not all roles. Only the RDS service role, disaster recovery role, and backup role. Deny all other principals explicitly. Enable key rotation. AWS rotates the key material automatically every year. Old ciphertext is still decryptable with the new key. This limits the exposure window if a key is compromised. Example, bad key policy seen in production, backquote. Allow principal to perform KMS on resource, backquote. Translation. Anyone with any AWS credentials can do anything with this key, including an attacker who steals a developer laptop with expired but still valid credentials. Secrets Manager replication for application secrets across regions. Your applications need database passwords, API keys, third-party credentials. Hard coding these is a security failure. Secrets Manager stores them encrypted at rest with KMS keys. For multi-region, secrets must be available in all regions. Secrets Manager supports automatic replication. Create a secret in the primary region. Enable replication to secondary regions. Secrets Manager creates replica secrets, encrypted with regional KMS keys. Example, a database master password stored in Secrets Manager in US East 1. Replicate to US West 2. Applications in both regions retrieve the secret using the Secrets Manager API. During a failover to US West 2, applications continue accessing secrets without reconfiguration. Replication lag, usually under 1 minute. Update a secret in the primary region, and replica regions see the update within 60 seconds. For credential rotation, this means a brief window where primary and secondary have different credentials. Design applications to retry a failed authentication once during the rotation window. Key security control. Secrets manager retrieval requires IAM permissions. Don't grant blanket "secrets manager get secret value" to all roles. Scope to specific secrets by ARN. The application role for the checkout service can retrieve the "checkout DB password" secret. It cannot retrieve the "admin credentials" secret. Example IAM policy for least privilege secret access. Allow secrets manager get secret value on resource ARN.AUS East 1. Account. Secret app/checkout per decibel password. Deny all other secrets. Condition. Only from specific VPC endpoints to prevent exfiltration via compromised instances with internet access. Real breach scenario. A startup with multi-region. All application pods had an IAM role with "secrets manager" on An attacker compromised a pod via an application vulnerability. They used the pod's IAM credentials to retrieve all secrets from Secrets Manager, including root database passwords and AWS access keys. Lateral movement to full account takeover. Fix. Least privilege IAM with secret-specific permissions. IAM policies for cross-region access without creating security holes. Your applications in US East 1 sometimes need to access resources in US West 2. S3 buckets with replicated data. DynamoDB tables. SQS. This requires cross-region IAM permissions. Naive approach. Grant "S3" on "ARN" OS3 . Translation. Access all S3 buckets in all regions. An attacker compromises one application, gets access to everything. Lateral movement paradise. Correct approach. Scope the IAM policy to specific resources in specific regions. Grant "S3. Get object on "ARN OS3 my app data-US West 2 / with the condition AWS requested region equals US West 2 . The application can read from a specific bucket in a specific region only. An attacker compromise has a limited blast radius. Additional control. Resource-based policies on S3 buckets. The bucket policy in US West 2 denies all requests except from VPC endpoints in US East 1 and US West 2. Even if an attacker steals IAM credentials, they cannot access the bucket from their laptop. They must be inside your VPC. Example mistake. A development team needed cross-region access for testing. They created an IAM role with full admin permissions in all regions. They left it attached to production pods. An attacker exploited an application vulnerability, inherited admin access, and deleted production databases across all regions. Incident cost: $4 million in revenue, $8 million in recovery, $20 million in customer compensation. Fix: separate IAM roles for dev and prod. Scope permissions to the minimum required. Zero trust networking. Never trust network location. Always verify. Traditional security model. The internal network is trusted. Once you're inside the VPC, you can access everything. This fails in multi-region. A compromised instance in US East 1 shouldn't automatically trust traffic to US West 2. Zero trust principles for multi-region. 1. Encrypt all traffic with mutual TLS. Episode 11's Istio Service Mesh implements this. Every pod has a certificate. Pods authenticate each other before communication. An attacker cannot impersonate a service without stealing the certificate. 2. Minimize network connectivity. Don't peer all VPCs to all VPCs from Episode 5. Only peer VPCs that need direct communication. Use private link for service access without VPC peering. 3. Segment workloads with security groups. Don't use the default security group allowing all traffic within the VPC. Create security groups per service. The checkout service security group allows inbound only from the API gateway security group. It denies all other traffic, even within the same VPC. 4. Restrict egress as much as ingress. Default deny outbound. Explicitly allow outbound to specific destinations. This prevents data exfiltration via compromised instances. Example: Zero Trust Architecture. E-commerce multi-region. US East 1 and US West 2. VPCs are not peered. Services communicate via private link. Istio mutual TLS between all pods. Security groups deny everything by default. Only API gateway to front-end service is allowed. Only front-end to checkout is allowed. Only checkout to the database is allowed. An attacker compromises the front-end but cannot access the database directly. Lateral movement is blocked. VPC endpoints and private link for AWS service access. Your EKS pods need to call AWS services. S3, DynamoDB, Secrets Manager, KMS. Without VPC endpoints, traffic goes through an internet gateway. The public internet. Even though it's to AWS-owned IPs, the traffic leaves your VPC. VPC endpoints keep traffic within the AWS network. 2 types. Gateway endpoints for S3 and DynamoDB. Interface endpoints for everything else. Gateway endpoints, free, no additional charges. Route table entries direct S3 and DynamoDB traffic to the VPC endpoint instead of the Internet Gateway. Traffic never leaves the AWS network. Interface endpoints. Powered by private link. They cost money. Each endpoint costs 7 cents per hour plus 1 cent per gigabyte processed. For Secrets Manager across 3 AZs, that's about $150 per month. For multi-region, deploy VPC endpoints in every region. US East 1 pods use US East 1 VPC endpoints. US West 2 pods use US West 2 endpoints. This ensures your security posture is consistent across regions. Security benefit. Bucket policies and IAM policies can require a VPC endpoint source. An S3 bucket policy deny all requests except from specific VPC endpoints. An attacker steals credentials, tries to download data from their laptop. Denied. They must be inside your VPC. Real security win. A media company, multi-region architecture, implemented VPC endpoints for all AWS services. An attacker compromised an EC2 instance via a vulnerability. They tried to exfiltrate S3 data. The bucket policy required a VPC endpoint. The attacker was on a compromised instance with an internet route, not a VPC endpoint route. Exfiltration failed. Guard duty detected the attempt, and the security team isolated the instance within minutes. Impact: 1 compromised instance, not an entire data breach. Common security anti-patterns that create vulnerabilities. Anti-pattern 1. Disabling encryption for performance. Teams benchmark Aurora, find encryption adds 5% latency, and disable it to hit performance targets. This is an unacceptable security trade-off. 5% slower is better than unencrypted data at rest. Fix. Optimize query patterns instead of disabling encryption. Or accept slightly slower performance for security. Anti-pattern 2. Shared admin credentials across regions. The same root password for all Aurora clusters. The same AWS root account credentials for all operations. A credential compromise in one region compromises all regions. Fix. Unique credentials per region. Rotate them separately. Use IAM roles instead of long-lived credentials. Anti-pattern 3. Overly permissive security groups. Backquote. Allow inbound 0.0.0.0/0 on all ports backquote for testing. and never change it. Production runs with all traffic allowed. Fix. Default deny. Explicitly allow only required traffic with source CIDR restrictions. Anti-pattern 4. No network segmentation. All workloads in a single VPC with full mesh connectivity. The database is accessible from every pod. Fix. Multiple VPCs or subnets with different security postures. The database in a private subnet with no internet access. The application tier in a separate subnet. Anti-pattern 5. Ignoring guard duty alerts. Guard duty detects unusual API calls, compromised credentials, command and control communication. Teams see alerts, dismiss them as false positives, and ignore them. A real breach happens that was flagged by guard duty days earlier. Fix. Guard duty alerts trigger investigations. Even false positives teach you about normal behavior. Defense in depth. Multiple layers of security controls. Don't rely on a single security control. Assume each control can be bypassed. Layer them so an attacker must defeat multiple controls. Layer 1. Network security. VPC isolation security groups network ACLs. An attacker must bypass network controls to reach your resources. Layer 2. Authentication and authorization. IAM policies. MFA for humans. Pod IAM roles for services. An attacker must have valid credentials to call AWS APIs or access data. Layer 3. Encryption. TLS in transit. KMS at rest. An attacker must steal encryption keys to read data even if they bypass network and authentication. Layer 4. Monitoring and detection. CloudTrail. Guard duty. VPC flow logs. An attacker's actions are logged even if successful. Detection enables response before a full compromise. Layer 5. Incident response. Runbooks for containment, forensics, and recovery. An attacker compromise is detected and contained before spreading to all regions. Example defense in-depth success. Financial services. Multi-region Aurora. An attacker exploited an application vulnerability and gained access to a pod. Network layer. The pod could only access Aurora via a specific security group. Authentication layer. The pod's IAM role could only read specific tables. Encryption layer. Data at rest was encrypted with KMS. The attacker couldn't decrypt it. Monitoring layer. Guard duty detected unusual database query patterns. Response layer. The security team isolated the pod, rotated credentials, and patched the vulnerability within 30 minutes. The attacker accessed limited data, couldn't exfiltrate it, and was contained before lateral movement. Before we wrap up, pause and answer these questions. Question 1. You're using multi-region KMS keys for Aurora encryption to enable faster drive. What security trade-off are you making? Question 2. Your application in US East 1 needs to read an S3 bucket in US West 2. Should the IAM policy allow S3 get object on for convenience? Question 3. Why should you deploy VPC endpoints in every region, even though they cost money? Take a moment. Answers. Question 1. You're trading regional isolation for operational simplicity. Multi-region keys have identical key material across regions. If an attacker steals the key from any region, they can decrypt data in all regions. Per-region keys provide better isolation. Compromising one key doesn't expose other regions' data. The trade-off depends on whether you prioritize RTO speed or defense in depth. Question 2. No scope the policy to the specific bucket and region. S3, get object on ARN, OS3, specific -bucket -US West -2 /. Add a condition AWS, requested region equals US West 2 . This limits the blast radius if credentials are compromised. An attacker gets limited access to one bucket in one region, not all S3 data globally. Question 3. VPC endpoints keep traffic within the AWS network, preventing internet exposure. They enable bucket policies requiring a VPC endpoint source, blocking exfiltration attempts from outside your VPC. They provide a consistent security posture across regions. The cost, around $150 monthly per region for interface endpoints, is insurance against data breaches that cost millions. Let's recap what we covered. First, encryption in transit protects data moving between regions. Aurora and DynamoDB use TLS 1.3 automatically. Application traffic needs explicit TLS configuration or a service mesh with mutual TLS. Never assume internal networks are safe. Second, KMS encryption at rest with a choice between per-region keys or multi-region keys. Per-region keys provide better isolation and slower drive. Multi-region keys enable faster failover but represent a single point of compromise. Choose based on your threat model. Third, Secrets Manager replication distributes application secrets across regions with automatic encryption. Least privilege IAM policies scope secret access to specific secrets and VPC endpoints. Never grant blanket secret permissions. Fourth, IAM policies for cross-region access must be scoped to specific resources and regions. Resource-based policies add an additional layer requiring a VPC endpoint source. Zero Trust networking means never trust network location. Fifth, VPC endpoints for AWS services keep traffic within the AWS network, enable bucket policies requiring a VPC endpoint source, and prevent exfiltration. Deploy in every region for consistent security. Sixth, common anti-patterns. Disabling encryption for performance, shared credentials, overly permissive security groups, no segmentation, and ignoring guard duty. All are preventable with a security-first mindset. Seventh, defense in depth layers multiple controls: network, authentication, encryption, monitoring, and response. An attacker must defeat multiple layers to succeed. This contains breaches and limits damage. Remember episode 13's compliance requirements? Security implements the controls that compliance mandates. The SEC requires immutable audit logs. Security implements CloudTrail and S3 object lock. MiFID II requires data residency. Security implements bucket policies enforcing regional restrictions. Compliance defines the what. Security defines the how. We'll see anti-patterns in episode 15 real failure case studies, what went wrong, how much it cost, and the lessons learned. Multi-region architecture mistakes that turned small issues into catastrophic failures. Next time, anti-patterns. Learning from production failures. You've learned the correct way to build multi-region across 14 episodes. Now it's time for the cautionary tales. The companies that tried multi-region made mistakes and suffered the consequences. You'll learn about split-brain scenarios where both regions thought they were primary, causing data corruption. Cost disasters where bills exploded to 10 times projections. Over-engineered solutions that collapsed under operational complexity. And the most expensive mistake: building multi-region without practicing failover, then discovering it doesn't work during real outages. Because learning from others, failures is cheaper than experiencing them yourself. See you in episode 15.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.